Word to the cloud. Awesome. Okay. So, oh, wrong one. This one. Okay. So today we're going to talk about and specifically how we are not going to. There are other to talk about. Yeah. We're going to get going very quickly. Let me just see if I can. Oh boy, hold on. Is that my microphone? Can you? Oh, it's Campus Wire. We'll look at that later. Thank you. Okay. I will look at those later, by the way. Thank you sometimes for should I give it a shot? Oh, we did talk about social. So today we're going to talk about cost. So that order is about study cost. And one of the lines that I want to be clear, I want to make the causal particularly the really easy, right? Like, here's what I'm going to do. Those are really easy to figure out. And the surface things are also really, really useful to have for science. So when we talk about those structures, it's not so much that one is superior to the other. It depends on the maturity of the literature that you work in. How much is known, more mature literatures, where questions, descriptive questions are subtle. You can start to think about causal questions, but if you're into causal questions, don't make any sense. You don't understand what's concerned. So it's important to know where your studies is. Along these lines, we're going to develop a theory of causal inference in order to help understand what exactly we're saying what state is possible. And then a little more clearly, what do we need to assume to get from our observational data to causal data? This is important because in lab experiments, it's pretty easy to make causal things, right? Like, I think this is a placebo, this regression of the focus on the source. The group that saw the video had the response, and because you control everything, you can say it's causal because like you isolate. One way to do an observational study in situations where experiments are expensive, unethical, or possible to run, what sorts of assumptions do we need to make on our data? How can we think through causality and when we can understand in actual observation? And that's what we're going to talk about today. So this is a story about a theory of causal inference. Before we get into that, some clarifications, and I just want to run through these to sort of situate, because we're starting the second week of precept tomorrow. Handouts are due 24 hours before precept. Readings are supplementary, but can help understand lecture material. More formally, by the way, and I think I'll leave the person anonymous, but I want to thank the person who emailed and asked me specific questions. Is there a name for a quiz or a problem set? If it's mentioned in lecture or in handouts. Okay, so if there's something inside in the readings that I never talk about, I will not ask you on this. All right. Cool. Precept assignments are not turned in. They're done in precept investigation, that's also practice 3. You have the answers, practice the code, so that we can find our own reals. Problem sets are released in the 3 days later after the syllabus, and quizzes will be this in data camp. Oh, there's an announcement out on data camp. That's all laid out for you now. The first introductory hour is due the Friday before break. Intermediate hour is due the last Friday of the school year of lectures. If you've already done these 2, or for some other class, just send me an email. We'll find some others for you today. I just care that wherever you are, it takes you and if you have some particular reason why you don't want to take these 2, but you want to learn Python or SQL or something impressive, and that's what it's like to do and get the data data. The last part of the data check is you guys are my hope is that some of you will just kind of take off of this and kind of take it. If you want to practice code, this is the best thing you do. So if you want to pick up R, you can talk about courses you take afterwards or Python works. If you're like, I want to learn Python or something like that, this is the resource to use. So I'm assigning the data camp less so that I can take courses and more so that you can grab it, understand it, and learn coding. So it's a tool that you can figure it out. So please, you will have a subscription for 6 months. So please take that as an opportunity to just keep on pushing as far as you want. All right. So the main idea today, we're going to talk about a theory of causal inference. And our theory of causal inference is going to be manipulability based. What does that mean? That we're going to ask the following question. If I were to take an individual, an observation, and move the treatment from 0 to 1, what effect will it have on that observation? So this is good to know when we talk today, that we're going to talk in a few minutes about the idea that there's no causation without manipulation. In order to make a causal claim, we need something that we need. We're going to talk about potential outcomes and counterfactuals. Potential outcomes are what the outcome would be under treatment, under control, or an observation. All of this is going to be without some detail. The counterfactual is the outcome that you don't observe. Counterfactual don't answer the conclusion of this theory because you need to clarify your counterfactual to understand what you're estimating. We'll discuss the fundamental problem of causal inference and a few assumptions. We'll talk about a matching exercise in order to get further into an example of what we're trying to do. So I want to differentiate descriptive and causal inference. If you take any other science course or stats or anything like that, the course is focused on certain things. These two things work together is a statistical. So you do a correlation or a difference in means or something like that, and you look for one test. So you will get kind of this course. Causal inference is more stringent than descriptive. It requires a randomized treatment. So in this case, what we're saying is not these two variables move together out in the real world, but if I were to manipulate this variable and move it, it would affect this outcome. They're different things, right? Correlations, yeah, right? Okay. It's approximated the gold standard is laboratory experiments, where you control the environment, manipulate something to the outcome, as well as approximated field experiments. And we're going to talk about natural experiments, which are cases where there's observation data, but under a set of assumptions, some of which are checkable. We can see or test whether or not it's will affect in certain situations. That's what we're going to start talking about here. So we'll talk about natural experiments and how to manipulate your data so that we can make causal claims. We're going to start talking about Stephen Colbert. Before he's about CBS, is it? Okay. He's on CBS. Now, before he's on CBS, Stephen Colbert played a character on Comedy Central called Steve Colbert, and he was America's leading conservative intellectual. To figure out his role in American society and American thought, it's sort of like if you were to take a question from Aristotle and Ataturk, and unite them into a single human being. This was Stephen Colbert. So he's kind of conservative thinker, and honestly, this anyone actually seen the show? Some of us have not seen the show. He was a wildly logistical lower. All right. And you can tell actually from the picture where he's okay. So let's see. We're going to return to Stephen Colbert in a few minutes. So before we do so, I'm going to run through a formalization of what we're going to do by causal inference. So, summarization. We're going to use the letter I to index observations. Sometimes the observations are individuals, in this case, they're going to be letter states. In this course, I will be used to index I as a subscript. We're going to reserve that letter for an index. Okay? X sub I means X for the I individual. Y sub I means Y for the I individual. And we'll write Y I or X I or T I or Y as a shorthand for an arbitrary observation. So just one random world case. We're going to reserve the letter T. Oh, sorry. I is going to run from 1 to n. Where n either upper or lowercase, we're going to reserve that letter for the number of observations. So it's the number of rows in your data set. How many observations are you doing? That's going to be n. And will not be used for anything else. We're going to reserve the letter T for treatment. Okay. It gets a little awkward when we talk about time down the line, so we'll have to find other letters. But we're going to reserve T for treatment. So if you see a T as a treatment variable, T sub I is the treatment variable for some arbitrary observation. We're going to reserve the letter Y for an outcome. And this is just all standard. So Y sub I is the observation. Y sub I is the outcome for observation, for arbitrary observation. Now, we're going to talk about potential outcomes. Let me just see one thing real quick. Okay. Before we talk about potential outcomes, that's where Colbert example for a moment. Stephen Colbert propagated the idea on the show that there was a Colbert effect. And the Colbert effect was this idea that by dint of showing up on Stephen's show, your life prospects improve. He was so amazing, brilliant, fascinating, and intelligent that it sort of rubbed off on people who came through. They were just lucky to sit next to him. This is actually a causal link. Right? If I go on Stephen's show, then my life prospects will improve. Grow some more hair, get in better shape, get a new car, vacation, whatever it is. And he advertises on a show in order to get what. So this study we're going to talk about is assessing the Colbert effect. He brings all the first word of James Fowler, brings all the tools of contemporary social science together on the question of does going on the Colbert report improve your life process? I do want to emphasize that I picked this paper for two or three reasons. One, it's one of the few papers I read that I feel pretty interested in. I'm not sure if you read a lot of political science papers, but numerous tracks that are matched. Sometimes the philosophers can get a little weak, but even then it's very good. The second reason is was a little aspirational after writing this paper that on the show. I just thought that was the entire paper was an audition for political science to go on TV. And so good. So that's the question we're going to ask is if a legislator goes on Colbert report, does it increase their donations? Right, so our outcome is going to be the donations that someone gets. The treatment variable is going to be whether or not they go on the show. And we want to know if someone goes on the show, does it increase their donations after they go on the show? That's the question we're going to ask here and try to develop an answer to. Now, if going on the show causes an increase in donations, what we have to do is develop this idea of a potential outcome function. The potential outcome function is a function for each observation that shows how they would have behaved had they gone on the show and that's in that function. So imagine, who's our random legislator in this house? AOC, right? Wearing a dress. So In order to figure out the causal effect of going on the show for AOC, for Ocasio-Cortez, what you have to do is imagine she goes on the show and it's a set of donations afterwards. Right? Then you have to imagine she goes on the show and gets a different number of donations afterwards. And the difference between those donations is the causal effect of going on the show. So imagine there's a world where she does go on the show, a world where she does not go on the show. The difference in outcome between those two worlds is the causal effect. The potential outcome function gives all those possibilities to the level of truth. So for Representative Ocasio-Cortez, yi of 1 is the donations that she gets after going on the show, if she goes on the show. yi of 0 is the number of donations she gets if she doesn't go on the show. The causal effect for observation I of going on the show is the difference between their outcome if they go on the show and if they don't go on the show. Right? That's how we're defining it. That's going to be our basic units. One of the nice things about this approach is it forces you to say things like, imagine she goes out and imagine she does not. And think of it through that as a singular observation. So, those are the potential outcomes. Let's lay out a few ideas here. The individual causal effect is the causal effect of an observation. If they go on the show, minus if they do not go on the show. So in this case, that's the individual causal. The average treatment effect, which is given below the summation, and if you're not familiar with summation notation, they can go through the last line. It goes through what that sigma is doing in the I from 1 to n. It's laid out on the last slide. So the average treatment effect is defined as the average of the individual causal effects. So we might take everybody in conference and say, hey, they go on the POL report. What's their outcome in terms of donations? If they don't go on the POL report, what's their outcome in terms of donations? And we subtract those two numbers. And that's the average treatment effect. So here's the problem. And this is kind of the fundamental problem of causal evidence. Can we observe, can an observation both go on the show and not go on the show? At any given point, we at best observe one reality, right? So the fundamental problem of causal evidence is there's always a counterfactual. We only observe one outcome. What do I mean by that? Let's say a Representative Ocasio-Cortez goes on the show. We don't observe what we observe her donations if she goes on the show. We don't observe her donations if she doesn't. One way to think about this. Well, we'll talk we'll go to the counterfactual first. The counterfactual observation is the outcome we don't observe. So if someone does go on the show, we observe their donations if they go on the show. But we don't observe their donations if they don't go on the show, that's the counterfactual. Right. So one way to think about the fundamental problem of causal effects. Imagine each observation has two known cards, each outside it. If they turn one is their outcome under treatment, one is their outcome under control. They can turn both cards over. Ideally, you want to turn both cards over and see what the effect is for that observation. But in the real world, only one of the cards gets flipped over. So we observe this one if they're in control, this one if they're in treatment. We can't observe both. In a random experiment, if you can just randomize who gets it, then it has to just have to flip over it. Right? That was treatment control But in a lot of observational studies, the treatment assignment is completely random like that. You want to adjust things. So the counterfactual outcome is the outcome we need not observe. So in this case, this is just a figure of all the data we could observe. So this is the observed data. So for units 1 from 1 to 10, we observe a set of covariates. What are the covariates in this case? the legislative party, what state they're from, how long they've been in office, their gender, their, how much they want their district wise, and so, okay? These are just variables that we have on the calculation. The treatment indicators, whether they go on the show or not. And that's what the ones and zeros are telling us. It tells us the people who go on the show and the people who don't go on the show. Then the potential outcomes that we observe, take a look at Unit 1. Unit 1 goes on the show. So we observe their potential outcome under treatment. We don't observe their potential outcome under treatment. Looking down at Unit 2, they don't go on the show. So we don't observe their potential outcome under treatment, but we do observe them under control. And this is the data that we observe. The question is, how can we back out an estimate of the causal effect, and what do we need to do to get there? So we're going to talk about matching as a strategy to better approximate causal effects. So this is some of the paper itself. It's a periodic error or causal innovation, right? From the paper. The best way to avoid selection effects, people don't want to show you how to completely random. The best way to avoid selection effects is to conduct an experiment to treatment and control. Thus, to really control for such effects, it would be best to randomly assign which candidates to run the show. I floated this idea to Stephen, but he disagreed with my calls, and that was Congress. So, ideally, what we want to do is just randomly assign which Congress members go on each show. But no one calls us that. Okay. What's the next best step? Can we create a counterfactual? But remember, the problem is that one of the cards turned over. We needed a decent estimate of the counterfactual. So the next best thing is to figure out a way to clone each candidate to appear on the program, make each clone run for candidates, and see what happens to their campaigns if they don't go on the program. But then we're stuck with twice as many Congress members. Our country does not need that. What is the culturally appropriate clone methods for this group? Is it Cylons or Star Wars, or is there any? For Star Wars? Okay. Not my favorite. Yeah, that's what you got, right? What's that? Fair enough. You guys need a good clone sci-fi base original. Okay. So we can't clone Congress members. And we can't take the people who go on the show and find someone exactly the same and see what happens to them. What we can do is estimate a counterfactual in the data. What does this mean? Well, what we can do is we can take your legislator and then go ahead and try to find someone who looks similar. So here's the details of how this works. There's lots of different ways. But what we can end up doing is for each legislator, we can try who went on the show, we can try to find someone who didn't go on the show and compare them. But we want to make sure the person that we compare them to is similar to the person who went on the show. So let's take Representative Castle-Cortez, right? She goes on the show, let's just say she goes on the show. What we want to do in order to find a counterfactual for her is to find someone from the Bronx, or at least from the New York City area, who's a newly elected Democrat, who didn't go on the show. All right, is anyone starting to find her? There was the, was it? Yes, thank you. Can you say that one more time so I can see his face and grab his name? Jamal Bowman. So you can pair up Representative Cortez and Ocasio-Cortez with Jamal Bowman. He's from the same general area, right? Okay. And you can look at the donations that Ocasio-Cortez gets after, and you can look at the donations that Bowman gets after, and take that as a pretty good estimate of the causal effect of the show. Yes, good. The math is correct. So, leaving that.
Ocasio already just gets some more public attention than Bowman does, so that reason she might get more
Yeah, so if you ask like any legislator, a member of the House to look like this, this general demographic, everyone shouts across the door just that day. Right? That's just, like demonstrably what just happened, right? She has a space in this idea of generally groups, large numbers of people with demographics, that no one else seems to, is that fair? Okay, and next one.
Does founder make any effort to prove that like compensate party donations at least 20 days of things that you think about, but like estimating donations?
Okay. No, he was just trying to come out of the POL report with the 6-day paper. Okay. I only hear a couple of these because they're calling me for the public category, so we're touching categories. Yeah.
Why would you find that like, for example, how much you guys see making like donations or like the night of the day after
Because the control group of her before versus her after should be going on in order to try to get more money. And then we can find those results. Because she's only on for some reason there. So what you want to do is compare it, it's like, does her before the show actually counterfactual with her after the show, right? Is that your question? We're going to talk about that design actually in the next lecture, it's called difference. So can you hold that for about one lecture? We'll return back to that. So you're a little ahead of us, and that's a good thing. Other comments on this? Yeah.
But this is a little bit back. In the beginning, we talked about how we test like almost retroactively. We can optimize the results, but there are consequences of that outcome. Then we can kind of like retroactively test.
Yeah.
Does that mean, so like as opposed to the lab or natural experience, does that mean that we are like into how causal like a connection we can actually make? Does that have to be sort of like, well, you can only be suggested as far as you're going retroactively, right?
Yes. So let me handle the three concerns that just came up and stress up. Okay. So the first comment that came up was variation of, well, we didn't actually, there's no one really match capacity for this student. Right, there's no control unit that matches her in terms of fundraising or anything like that, right? Like just to hit the things again, she works with us and that and all goes to mix, right? That doesn't happen for her. Let's see if I heard that. Okay. So the concern that as it's formalized that, they're arguing that at some level, they're arguing that there's no control that matches the truth, right? And that's fair, and that's always the case here. You never have an exact person, you need to do it sense of stuff, right? Your comment was, well, maybe we have these covariates that are maybe doing it, but do we know these are the right covariates? Do we know we have enough of them? Do we know we're not missing them? Is that fair from what you're saying?
Yeah.
Right, we choose the right variables and match them up great way. That's another thing about that. Okay, there's some research on that now, but it's not the sort of thing that we have established answers to. That's where substantive knowledge comes in. Where like as political scientists, we go, well, if we get party and competency and a couple other things, we assume it's close enough. Okay. But if you hear my sort of shrugging, it's close enough for us to move ahead, that's what's underlying this. Okay. The last comment was, well, how causal is this, right? And in order to estimate a causal effect in an experiment, we just need to learn this. In order to estimate it here, we're going to need a few more assumptions to get us there. So we'll get to those in the next slide. It's not that short. The key difference is that when you run an experiment, the treatment group and the control group are the same in all of your covariates, and then everything else we did today to measure, which comes back or back on the measure. When we can match it, we're only matching on observed. So we need to make sure that the variables that we're matching, in this case, the competency years office, there were a few others, that's enough. We need to make sure that's enough in order to make a causal claim. And I'll formalize what we mean by enough. Maybe in the next slide, but it's coming up shortly. So what does he match on? Incumbency, party, and donations in the previous 20 days. Is that enough for a top political science publication? Honestly, no. Is that enough for like a thinking example that gets you on a cool TV show 10 years ago? Yes. So the idea behind it is that for each observation that goes on the show, so if observation 1 goes on the show, you observe what we're going to do is we're going to go to the data and find someone who's similar on observed covariates and match them up. And do this pairwise. So we're going to compute the missing counterfactual using matched observations. So everyone who goes on the show, we're going to find someone with the same party, incumbency status, similar donations in the last 20 days, and say, well, that's close in terms of how we're defining it. Put them together. Then we'll have a treatment group and a matched control group. And we're going to analyze that as an experiment. Was it an experiment? No. With enough covariates, formally we can show that we can actually get to a causal effect. So the argument that we're making with matching is that if the observed covariates, for someone who's looking at causative correlates, if the causative correlates is covariates, for incumbency status, donations, that sort of thing, are sufficiently close to somebody else's, then we're assuming, or we're arguing, we're hoping that had Cortez or causative correlates not come on the show, her number of donations would have been similar to this other person who was similar on these covariates. Okay? And that's really what's doing. We're assuming that people with similar covariates that didn't go on the show would have gotten the same outcome as had that person not go on the show. So the questions that we're asking about doing is sort of covariates that turns out to be like the whole thing. If you observe enough to actually match things properly, you can make really strong claims. There's always a lingering fear that you're missing something, but you can't prove that you didn't include everything you did. So one of the critiques of this general approach is like with experiments, and in front of you go, we randomized who went in to go get a job. And we randomized the elements on their residence that are the same number and felt good. When you drill down into these studies, you start to get a sense of, I hope that's close enough. And we'll formalize that again in a moment. But I want to get to just some of the distinctions between these two types of studies. So there's some notation, and I will let you know you can feel free to skip the notation. Slide, okay? I put it up here for completeness. If you want to go read this, they're continuing through in this vein. This is a good slide. For your purposes, the assumptions, we can focus on just the first line of each. All right. So in this case, we have to talk about the assumptions. The first is called common supports. This assumption was brought up by the first question. It said a valid counterfactual exists in the data for each observation. So, when someone raised their hand and said, no one is comparable to a causative correlates in terms of fundraising, then you're questioning the common support assumption. There's no control observation that's sufficiently close to her in terms of fundraising star power to actually get this, to be able to match. So that's calling assumption 1 of the question. Assumption 2, all confounders are matched. Now that just means we have complete covariates that we need, and that was the second question that came up. We need to assume that we've done something, that we've matched them with things that we need to match them. Assumption 3 is sum. And it shows up as referred to as the stable treatment assumption. And it's the idea that there's only one version of the treatment. This is designed to mimic pharmaceutical experiments, where someone gets like a pharmaceutical drug or a baby soda. And there's only one type of baby soda, there's only one pharmaceutical, right? So treatment is a singular thing, control is a singular thing. Is that the case here? And this is where more attention has been drawn to this, especially in political science, but there's just a bit of statistics to this assumption. This assumption is a little more subtle than you think. So let's just presume for the sake of conversation that there's one way to go on the Colbert report. You just go up and sit next to Stephen and he does this movie, he goes to single autonomous thing, and you sit next to him and talk. Okay? How many ways are there not to go on the Colbert report? One? Oh, there's at least, what's the one you're thinking of?
Not go on it.
Yes, but when you don't go on it, what do you do? You can go on another show? Anyone else? You can start your own show. You can have a Twitter conversation. You can have a fundraiser. You can call donors. You can go to a community meeting instead, right? There's only one way for art. There's only one way to develop the show. There's lots of ways to be in control. And when the classic books, they talk about this, where figuring out the possible effect of going to college on leaders or rankings. Why? I mean, again, for conversation, let's say there's one way. There's not, we all have our own series, right? Let's just posit that. How many ways are there not to do this? You can go to mail. You can join the military. You can say you're going to write poetry. I don't know. There's lots of different possible control conditions. And the point of this assumption is to force you to say what is the actual control condition I'm talking about. So in this case, again, like starting a joke, this was a bad paper. If you were taking the paper much more seriously, we'd ask of those in the control group that at the very least if they want to have other shows. And these are actual people who called up and say, instead of going on a show, what did you do? And again, at the very least, you should compare people who went on the show to people who didn't go on the other show. Okay. The last one, non-interference, assumes that there's no spillover class. That a classic organist doesn't go on the show and gathers up with the squad afterwards and goes, this was awesome, you should do it. All right. Or you guys actually like you, which is a complete joke. Don't go on that show. We're assuming that there's no spillover class. It turns out we can't actually work around this assumption with it if you model the spillover effects with that. So we're going to assume that one person's treatment doesn't affect another person's treatment, and one person's treatment doesn't affect another person's outcome. So here's the Colbert bounds. This is the main figure of the paper that's sort of made more background. The y-axis is monthly donations as the number of Democrats, the absolute difference between Colbert candidates and others. Then we see Democrats in trouble on the lower left, Colbert on the upper right. Anyone want to take a stab at these pictures? What this graph is conveying? Aside from when you write the figures for me, you should have 3 lines on the y-axis that makes my look like this. Take a minute with this. Yeah.
Very temporary entry. A sort of 9
So if you're putting out that it's about 30 or 45 days after, right? Okay. Other comments on this? Over.
People that went on the show were like people that were doing worse beforehand.
Which kind of calls into question the entire enterprise, right? Prior to going on the show, you want to see where it says Democrats in trouble, you guys should want that to be a flat line and 0, right? Which means there was something a little off in the match. The match didn't come back. As a random historical aside on this, but an important one, not actually a work on this, they on television. And that sort of the thing you see on the left-hand side was the start by a common theory called the action culture. And it's actually called action culture today. right, labor economists, because labor economists have been doing this forever, in terms of the job training program, let's intervention, you know, like that sort of. It dates back to late seventies, 1970s, but then, early national was back in the 70s, he's awesome, by the way. But that is beforehand is that we didn't actually not previous periods. So instead of mentioning a previous 60 days, you should have actually had a previous 5, and 20 years that over. The first thing that went up, and never happened. Oh, nice, I don't know, sorry. Yes. Yes. Which kind of goes against the fact that generally in social sciences, the stance I'm going to take is the past affects the future. But as if people are going, wait, I'm going to stick with that there's no anticipatory effects. But this looks like one doesn't. Right, that it's starting going up prior to going on the show. Could it be that people were announcing they were going on the show and fundraising on it? Maybe, but that's the sort of thing that as a social scientist you should go on. Okay. So a couple of takeaways. One, the action wasn't well successful. If it was, it would have been a straight line from the left over. The second thing is someone point out that the effect actually keeps about 4 to 5 days later. So what are we saying? Yeah, well, someone goes out to POL report. Then about 6 weeks later, people in their district go, you know what? He was on the POL report for 40 days ago. I'm going to send this person 1 month. Does that match at all to how people work politically? No. Does anyone wait, like, if anyone looking at me? Whatever, obviously. I mean, you can, but it's, I'm not saying. Did you wait 6 weeks after you were motivated by them to send off? It was relatively immediate, right? That doesn't match the story. So it seems like what's happening is a combination of action colors, which will never be an example of like $1,000 on January. Do they have any poster about it? The one guy got fired because of stuff, right? Okay. So it might sound like that. But the action is not successful with the flat line. And the fact that the dish shows up 30 to 45 days later, is just not close enough. But this paper didn't get on TV. So there's that. So it was a success in that regards. A few different ideas to lay out. Let me see, hold on. We need to lay out the average treatment effect versus the average treatment effect. It's an odd distinction at first that your brain will, with other makes more sense. I've never had anyone who just got into the first price will several times. The average treatment effect is what we get in this term. You say, here's my observations. I want the average of, I want the effect of the treatment on this entire group. So I'm going to get half the treatment, half control, just measure government, right? A more useful estimate, something we're trying to estimate, a much more useful estimate in the policy world, and most of the social sciences is the average treatment effect. For those who did something, what was the effect on that? And that's how the average treatment effect of the treated shows. So if you're running an experiment, it's the average treatment effect estimate, if you compare simply if you're estimating the effect of a policy, it's the average treatment effect of a treaty. What was the effect of entering a charter school on those students who did? What was the effect of a job training program on those students who did? What was the effect of a Pell Grant on those students who don't? And so forth and so on. So the average treatment effect of the treated wants to know if there's a group of individuals that were exposed to some treatment, that was some direction that they highly selected people were exposed to, what's the effect on that? So the matching exercise that we just did was average treatment on the street. Instead, of the legislators who run the POL report, what was the effect on them in terms of donations? It's important to keep those two separate. We'll have a few more examples going forward. Experiments, field experiments are always ATP. Policy analysis are normally ATT. What was this effect on this policy? Alright. The ATT is essential to program evaluation. Causal inference in a nutshell. No matter your study, I try to ask this to every study that I read, or grad students or senior PTs or that sort of thing. Causal inference is nice theory, there's a lot to it, but just as much it highlights key concerns and questions that you have to ask in any study. The first one is, what is your ideal experiment? If you could run an experiment to answer your question, what would it look like? Tell me. Answer that for your JPC piece, always. If I could run an experiment, yes, you are a living, not a mission. And you decide to call that power for your pieces. Then, what experiment would you run if you could? The second is, what is your counterfactual? Your counterfactual, I'm going to correct the example now with the two others later. But actually state your counterfactual, imagine some, so you're didn't go on the show. And if you find that you can't state your counterfactual, or that doing so makes you laugh, that's how I started most of the counterfactual required to actually observe and not observe. Right. Yeah, right? So in that sort of thing, it's just give you pause and go, are you actually any sort of problem? If not, you're still left with a description that is tolerable, but be careful that you know what you're doing. You estimate your counterfactual, and that's what's particularly important. What is the mechanism? We always find the best, but what is driving the effect? What is actually connecting between the treatment and the outcome? What is in the middle that's making things change? All right, I will see you next subject. That's